So my name is Ori. I'm the CEO of Montara, and with me over there is Dadi, our VP product. And today we wanted to talk to you about the analytics development lifecycle and how we propose to tweak it in order to also enable data analysts to take part in data development and make analysts super productive. So we'll go through what is the analytics development lifecycle and what are the downsides of the ADLC and how it excludes many stakeholders from taking part in the analytics development process, and then how we can democratize the process and take a different approach. And when we finish talking about the concepts, Dadi will actually walk you through how Montara does this and what are the different capabilities that we think a modern analytics platform needs to have in order to enable organizations to be very, very productive. So let's get started. So what is the analytics development lifecycle? As popularized by DBT, at the end of the day, it is kind of an offshoot of the software development lifecycle, right? But adapted for analytics. It starts with planning. What do we want to do, of course? And then moves on to development. So development is the actual coding, SQL, Python, what have you, of the code that generates tables in the data warehouse and gets them ready for later stages, AI, analysis, dashboards, reports, etc. When you finish developing in a modern process, you obviously want to test everything. After processing, you want to deploy it in a thoughtful manner and ongoing, make sure that everything is deployed correctly. And then operating means pipelines. How do we run data pipelines on an ongoing basis on top of that code we created? Observing means how do we monitor everything to make sure it works well in the production environment. Discovery is very important because discovery is where everything then gets exposed to the organization. If we created tables in the data warehouse and they are ready for people to use them, how do they find them? How do they know what's in those tables, etc.? And then the actual work, the analysis itself. And over time, people do analysis, realize they need more stuff, they plan, and they go on and developing, and this process goes on and on. So let's take the most common scenario where data engineers or analytics engineers use DBT in order to support this process and go through what is needed in today's world in order to be able to do analytics development or prepare data for analysis. So the first thing is, if you use DBT or any other platform, you need to code. You usually code with SQL or Python, and then use other technologies. In the case of DBT, you probably have to use Jinja, macros and stuff in order to be able to develop efficiently within that environment. Once development is done, you want to build tests, you want to build unit tests or whatever you want to call them. So in an environment like DBT, you, at the end of the day, write tests within YAML files. You have to manually go in and edit files. And then in order to test everything to see that it works, you have to spawn some kind of test environment and then go ahead and deploy your code into a test environment and test everything, right? If tests work well, you have to go on and then start deploying. Deploying is the CI/CD process. How do we, in a predictable way, package the code and move it into a production environment and do it ongoing, right? So this whole process requires pull requests and Git and all sorts of processes that you have to put in place in order for the code to go from the development phase to the test phase and then to the actual deployment into production. Now, once you have the code in production, you have to run it on a regular basis so the tables are refreshed with new data as data is ingested from different systems in the organization or from outside the organization. So usually that means opening up some command line tools and creating pipelines and orchestrating pipelines with tools like Airflow and others, or Jenkins or what have you, in order to be able to actually run the code in production every time new data comes in. Now, once you have that process set up, obviously you want to make sure that everything works, right? So you have to monitor the data in the data warehouse to make sure that things get updated, that the data is fresh, etc. Usually that means another tool, usually an observability tool, maybe like Monte Carlo or something like that, that you set up in order so you'd be able to monitor everything that goes on in your data warehouse. And then for discovery, so that you can discover the data, so you can understand what happens in those tables, you need to document everything. So in dbt specifically, this means opening YAML files and actually manually writing what's in every column, what does the table contain and hold in terms of data, and that then gets pulled into data catalogs, okay? So the reason why I go through all of this is if you think about this process, it requires a lot of understanding of engineering concepts that were brought in from the software development world. You have to understand how to test, how to write tests, how to move between environments in order to deploy your code into a test environment. You have to understand how the CI/CD, right, the continuous integration, continuous deployment process works. You have to understand how to orchestrate pipelines, run things in a predictable manner, use tools like observability tools, etc. It's a complex environment and a complex process. The good thing about this is it creates a predictable quality flow of data into the data warehouse instead of what used to happen in the past where you just ran SQL in the data warehouse and there was no versioning, there was no deployment, there was no testing. It was much harder to do. So the adoption of the analytics development lifecycle in organizations is a good thing, of course. The problem is the complexity creates a situation that we call the dark side of the analytics development lifecycle. So because this is such a complex process and requires many, many steps and working with different tools, etc., usually what ends up happening is that only engineers can take part in the analytics development lifecycle. So if you're an analyst and you know how to write SQL and Python, you basically can code. But all of those other things we talked about, the deployment, the testing, the observability, the pipelines, all of that stuff is not stuff you're trained on or expected to know how to handle, which means that you cannot take part in the data development or analytics development process. What this means is anytime an analyst has something they need to happen in the data warehouse. So maybe I'm a data analyst, I did an ad hoc analysis, I realized I want this as a table in the data warehouse that refreshes every day because I want to build a report on top of this and I want it to become part of a dashboard. I don't want to manually run this every time, right? So I wrote the code, I did the analysis. If I could just go to the data warehouse and put that code in there so that a table is created for me and refreshed, I can go on about my job. But I can't because I don't know all of those tools and all of these processes and steps that we talked about. So what do? I go to data engineers or analytics engineers, depends on how you call it in your organization. And I usually open a ticket and I wait for them to free up in order to help me, right? And then I wait, okay? And that part of the friction between analysts and data engineers slows down organizations significantly. In most organizations, from our extensive experience, there are probably 5 to 10x analysts to every data engineer. So you have a situation where analysts work. They work in a very dynamic environment, right? Maybe you're a finance analyst and the VP finance comes to you and says, hey, I have a meeting tomorrow. I need this report ready by evening, right? And you look at the data warehouse, you realize you don't have the data. Well, now you have to wait for data engineering. It actually slows down everything. And it creates a situation when bottlenecks are created, insights are delayed, and it gets really, really hard as the organization grows and there are more insights and more demand for analyst work on reports, dashboards, insights, etc. So we suggest a different approach. We think we need to tweak the analytics development lifecycle so that more stakeholders can take part in that process. Because if you think about it, the beginning part of the process is development. It means SQL and Python coding, which is something most analysts know how to do. And sometimes it's data scientists or product managers. If they could only master the rest of the cycle, they could move much more quickly and their whole organization can excel at getting insights. So the idea here is how to integrate data analysts into this development process in a way that, on the one hand, relies on the existing skills the data analysts have, right? Knowing how to write SQL and Python that generates insights, that actually does something. But abstract away all the rest of the complexity. Because if we try, and we see it all the time with our customers, many times what happens is the organization says, okay, we need to move more quickly. Let's train analysts on all of these things that I just talked about. But then they have to become kind of data engineers, right? And it's not their job. That's not why they get hired. They get hired in order to analyze data, understand the business, and create reports, dashboards, insights, ad hoc analysis, etc. So by trying to actually force them to learn all of these things that data engineers do, we take a lot of their time away from the core job, which is insights and analysis. And it's not something that they're good at. It takes a lot of time to train them. It's just not the right approach. So how do we make it happen? In the last few years with the advancement of AI, we can really utilize AI agents, copilots, etc., in order to let analysts take the code they already know and write and get everything beyond this done by AI for you, which Dadi will actually demonstrate in a minute, how AI agents can actually write the tests for you, can document everything for you, can create data pipelines for you. You as an analyst, you already know how to code SQL or Python, go into the proper environment, put the code in, and let the AI agents do the rest of the work for you. The other thing is the importance of an end-to-end solution, because if you have to switch between different tools, one tool for data pipelines, maybe Airflow, one tool for observability to make sure that everything works well, maybe Monte Carlo, go back into dbt and manually work within files or whatever, you're not going to be able to do it if you're an analyst. It's not your job. You don't need to jump between different tools. This is exactly why we have data engineers. So the idea is if you have an end-to-end platform that takes care of everything, you as a data analyst can focus on writing the best code, okay? This means we have to manage everything so that the analyst can work within one environment. So you got to have the ability to have something manage deployments for you. You don't want the analyst to bother about, well, how do I take code that I just wrote and deploy it to production, right? How do I deploy the code I just created into a test environment and test everything? All of that stuff has to be managed. And the same thing, sandboxes, all of these things. How do we create sandboxes that have data that we can test stuff in? You don't want to get bothered by this. You want to, as an analyst, just take the code you wrote, put it into a system, get everything else done for you, go back to your Tableau, your Power BI, your notebook, whatever, and continue with your analysis work. And obviously, this will require a lot of governance and guardrails because if you're an analyst and you're not expected to learn this whole complex process and all the tooling, then we need to make sure that you stay in your lane and you do the stuff you need to do, and everything else is either done for you or we can protect you from not making mistakes. So let's take a look at the analytics development lifecycle we saw a minute ago and what it looks like if you abstract a lot of the complexity away. So the steps are the same, but how you go about them as an analyst is different. So development, same old SQL or Python, but this time around, hopefully there's a smart AI copilot that helps you with everything you need so that you can write quality code, okay? And again, Dadi in a minute will demo what this means. In terms of testing, you don't need to understand what it means to write data tests. You don't need to understand what it means to set up a sandbox environment. You need to have a managed environment. You need, and we will show you how this works, an AI agent that actually can look at the code you wrote and set up data tests for you. Because the minute the AI agent knows what you are planning on doing in terms of SQL or Python code, there's no reason why we can't write complete data tests for you and not have you have to do anything. That's the beauty of an AI agent that is dedicated for something like this. Then in terms of deployment, again, we don't want analysts to know what a deployment process means. What is CI/CD? What is continuous integration, continuous deployment, all of that stuff. All we need is to understand that you put your code in, you like what happened in the test part, the test work, and have passed. And then if that's the case, you can just decide that you want to release it to production. There has to be a whole process, a managed process behind the scenes that takes care of everything, and a good platform does that for you. Now, in terms of operation, building pipelines, Pipelines are very complex sometimes. We see companies where they have 300 or 400 different tables or models that they have to orchestrate what runs before what is dependent on what was the upstream, downstream, all of that stuff. But there's no reason why AI can't set it up all for you. So as you'll see in a minute in Montara, our AI agent analyzes all of the tables to understand what needs to run when. You just have to say what you want to run and how frequently you want to run it. Do you want to run it every morning, every evening? Do you want to wait for data engineering to do ingestion and then trigger stuff? But the actual setting up of this whole thing is done by AI for you. And then observability. It may sound a little kind of weird, but why don't we automatically just monitor everything the minute it starts running? Why do we need another tool? So we bake in to Montara a whole monitoring solution. Every time something is created in Montara, there's automatically monitoring built in to alert if something goes wrong, instead of you having to go to another tool, etc. And in terms of discovery, and that's the easiest step, there's an AI agent. You should have an AI agent, basically documents everything for you. Looks at the code, understands the code, deeply understands the rest of the stuff, the schema that the organization works with, the work that you have done before, the nomenclature of the organization, the abbreviations, how you used to document other stuff, learns from this and then documents everything else. So documentation is done automatically for you, and then it gets exposed to data catalogs if needed, and discoverability happens. And then obviously you move back to analysis, meaning, okay, I put my code in, AI took care of everything else, I can go back to analysis because I have the data available to me in the data warehouse, and I can run my dashboards, reports, and analysis. So that is what a modern analytics development lifecycle should look like if you have the right capabilities and that enables more people to take part in the process. And organizations that work this way, from the research that we have done on our customers, are 2 to 4 times more productive, because a lot of the day-to-day back and forth between analysts and data engineers are on those small things that analysts can actually do on their own if they have a solution that enables them to work and abstract the way they need to work, which is code, everything else abstracted away and automatically done for them. So we talked a lot about processes and how this works, etc. Ideally, and this would be the best thing, we'll show you what it looks like in the real world. Dadi will simulate an analyst going to work, having a project, needing to do something, going into a system, and getting all of that done for you. So thanks, Dadi.
Thanks, Ori. Can everyone hear me?
Yeah.
Great. All right, it's demo time. Okay, hey everyone. My name is Dadi. I'm the VP of Product at Montara. And we're going to just start with this easy common scenario. Say I'm an analyst, and I've done some ad hoc analysis, or I want to run a monthly A/B test, or I have this custom query in Tableau that's taking forever to run, and I've asked my data engineers to create a table for me to speed up this thing. But now with Montara, I can do it on my own. All right, so I'm going to choose to create the table from existing code. Let's give that table a name. Let's call it Rev Analysis. And let's paste in my code. Okay, so let's start by previewing the data. I must have done it before, but let's just make sure that everything makes sense. And I can view it on a tabular level, but I can play around with the look and feel and just make sure that everything makes sense. Cool. Next up, I'm going to set my refresh schedule. So I want my table to be refreshed at 3 a.m. and I want to run daily. Okay? So I'm going to hit save and run. So as you can see here, according to my project policy, this table is going to be retained for 1 month. So this, Ori mentioned a lot about governance and guardrails, and this is the first thing that being applied here. So my table is going to live for 1 month. So analysts can do whatever they want. Only the admin or the data engineer or whatnot can approve it. So I've compiled my code. I'm starting to run it. And this is being done in real time. My table is being populated. We sit on top of your data warehouse, so we don't store nor process any data. And this query gets executed, and data is being filled. Another thing to note is that Montara connects to your data sources with read-only access and writes to a dedicated schema. So this table was created in my isolated schema with 15,000 rows. Cool. So next up, a few days passed, and I want to make changes to my table. Say I've found that there are some empty values and things are looking funky with my table, and I want to remove all null values, right? So as Ori mentioned, AI is fully baked into the product, so we're going to start with the Copilot. Compared to just dumping my query into ChatGPT or other tools, the key here is to understand is that context is everything. We know everything, the tables, how they relate to each other, the columns, so the Copilot is extremely powerful. So if I want to, for example, remove empty values, I don't need to specify the warehouse, the columns, how they relate to each other and whatnot. So it's a truly delightful and powerful development experience. So the interaction here is I'm adding null values, I'm inserting it into my editor, I can preview the data, and this goes back and forth and really improves my productivity when coding and working with data. And I don't need to do anything else but bring in my SQL and Python skills. So say a few more days passed, and I'm taking a look at my BI tool, Tableau or whatnot, and something looks off in my data. And by backtracking it, I understand that something is wrong with my table, and I want to add some more validations to it. So this is our validation agent. Instead of, again, opening a ticket, adding some validation tools, writing YAML files, and doing those tedious works, our validation agent is doing a bunch of validations for me automatically. First, it enforces the schema of my query. It analyzes my code, understands the columns and their types, and if some upstream table, and this always happens, changes the table, changes the columns, changes the type of one of the columns, this table is not going to run, and I'm going to get notified, of course, and that data is not going to flow into my BI tool. I can add some manual additional validation, but just give the validation agent, let it do it for me. So, and again, the more validations I add and the more interactions I do with the AI agents, it's going to get a deeper understanding of the culture, as Ori mentioned, the nomenclature, and like how we go about things. It's going to get extremely more powerful. Another tedious task after creating my table is people peeking on me, asking me stuff like, what does this column do? What does this table do and whatnot? And I need to document it somewhere. It's either in a dedicated data catalog that I'm going to do it manually, or some sort of Google Sheets and other cumbersome places to do it. But the documentation agent does that for me. If we have specific acronyms and stuff like that, it's going to know that, and it's extremely powerful. And later on, as I show the data catalog, this is where I'm going to actually be able to consume that information. Another major friction point between data analysts and BI developers or data engineers is the ability to run my tables incrementally, right? I don't want these nightly extracts to be running on the entire data set. I want to make it an incremental table. And in Montara, it's just a matter of a few clicks, right? So I set this table as an incremental table. I specify the key, the columns or the combination of columns that determine the key. For each data source and everything is being done automatically. For each data source, I need to specify the partition or basically the column that determines the date of that record. I can add a sliding window. And since I'm constantly adding more records, I can define a data retention policy to delete old records. So it's just a matter of a few clicks. Our customers are heavily using this, and it's truly like delightful on the one hand and a cost saver on the other, performance and cost. Okay, so let's make some changes with my code, for example, to this and try to save it. And what gets prompted here is it tells me that I did not add any validations to my code. Now, part of the governance rules, which I'll show later on, enforces these strict guidelines for analysts to make sure that older models are documented, they have validations if they want to. Now I'm getting a warning, but it can actually prevent me from creating new versions if they're not validated or documented, to enforce best practices and make sure that they don't create additional mess and bad code. So I'm going to save it anyway. And I have unpublished changes. And again, the abstraction level, or the level you need to engage with here, is not git commit and all that, although the underlying infrastructure is a Git repository that's most of the time being hosted at the customer's premise. So I'm feeling good about my changes, and let me publish that version. And now what Montara is asking me for is to test my changes before promoting them to production. By hitting test changes, Montara automatically spins up a sandbox for me to run my changes. You can see that it's going to run the change tables and whatever tables is impacted from that change in an isolated sandbox. I'm going to hit run, and it's going to run my changes and all the validations to make sure that everything is rock solid. So this gives me additional confidence in the changes that I'm making. Yeah, do you have any question?
Yeah, where does it get this data from?
Come again?
Where does it get this data from?
So Montara, by spinning up a project in Montara, we connect to data sources. These are basically like the tables that we have read access to, and we build the tables upon. So these are the sources that, so by creating a table, you query one of the sources, and you can build additional tables on top of that. That
basically, when you spin up a sandbox, we take data from the data that was mapped to this project, bring it in the sandbox, run your code on it, show you that it worked correctly, and then you can continue. You don't
And
have to worry
it's being done on a smart basis. So it's querying. So if the tables are not changed, it's going to defer that to production and pick up the tables from there. So it's going to run only the changes, basically. OK, so I'm done with my tests. Here are the models that were ran. Here are the validations. All look good, and I can publish my version and go about my day. By publishing version, I can specify one that's submitted for approval. And this is also being done under the Montara umbrella. Or I can just publish my new version. We have a complete version management system that sits on top of your Git repository, so you can compare versions, revert to previous versions in case something goes south. OK, so I have my table. It's being refreshed daily. All is good. But for the most part, you have dependency between tables, and you want to make sure that one table passes, and then you want to start up with the other table. And for that, we offer what's called a pipeline. A pipeline is a way for you to group tables together and somehow schedule or trigger them. So when configuring a pipeline, you basically need to specify which models you want to include as part of that pipeline. But in terms of orchestrating them and deciding where to put that in the correct order, we do that for you. So imagine a project with hundreds of tables, and you created a new table. You don't really know, if you're working with Airflow and other orchestrators, where you're going to exactly place that table in the order of execution. So it's a major hassle that's being saved by Montara. You just determine which tables you want to include and define a schedule, as you've seen before. Or you can trigger it externally via webhook or an Airflow operator that we have. So if you want, for example, do all the ETL stuff or the ingestion and then trigger Montara and then do other stuff, you can do that. It fits perfectly with additional DAGs or orchestrators. So now that I have a lot of tables and a lot of pipelines, things can get out of hand quickly. And we're going into the observe part of the analytics development lifecycle. And luckily, Montara monitors all your runs automatically, so you can make sure that everything is healthy. So when you go to observability, you can take a look at all the pipeline runs. For each pipeline, how long it took for it to run, which version it ran, take a look at all the tables that were running as part of it. And from a model or table perspective, you can answer questions like which model is taking the most time to run, how many rows, what's the data version of each table, and drill down into specific table runs in terms of their row count and how long it took for them to run. So complete visibility and confidence that everything people are doing is healthy and no issues arise. So now I've created my tables, I've observed them, and now I need to know what are my data assets and what's the best way to use them. And for that, folks are going into our data catalog. So the data catalog is being automatically, as we've seen before, documented, but you can quickly search for columns, for code, and other assets, and essentially consume that information from that we did before. In terms of lineage, I want to understand, and that also applies for when working on a specific model. Let me first show it on a model level. So say I'm working on this table model. I want to understand the impact of my changes, right? So what tables, or more importantly, what dashboards are using my current table. So this is also being done on the model, on the column level, and gives me additional confidence and context in terms of like the impact of the work that I'm currently doing. Yeah, so let's talk a little bit about governance and rules and all of that. So we've given analysts, and it can also be like product managers who knows a little bit of SQL, and we give them permission to access specific tables and do whatever they want with them. So a lot of data practitioners that can participate in the data development and create tables in the data warehouse. But the flip side of it is that things can get out of hand quickly in terms of coding best practices, cost, performance, and all of that. So by applying a set of governance rules, you can make sure that everyone is aligned into the same process, right? So we talked about retention models. So we can specify how long a table lives in the data warehouse, and then it gets deleted unless it's approved. You can require data validation, documentation. You can require that every model needs to be an incremental model, right? So for the most part, it makes sense for models and tables to be incremental, and you can enforce it on each one of your models and all of that. You can set pipeline timeouts. So a lot of our customers are saying, okay, let them do whatever they want. After 15 minutes, your pipeline is gonna end. So it's up to you to make sure that everything is performant and works as expected. So on the analytics side, you get a lot of independence, empowerment, and on the governance engineering side, you can make sure that everything is rock solid, doesn't get out of hand.